In this video, we will learn about build max heap. This is a new function and will be using in will be used in heap sort. So as I have learned about max heapify function, if you don't know the max heapify function, then you can see the past two videos. Those two videos relate to max heapify function because this present function build max heap is dependent on max heapify function. And as usual, to understand this function as well, I have to first take an array. So I am taking an array. So here you see I have taken an array of size 12. Now I am going to form a heap. Now you see I have formed a heap from the given array. Now we have to understand this build max heap function. To understand this build max heap function, we have to observe non-leaf nodes and leaf nodes. So obviously I say here non-leaf nodes and leaf nodes. So I am going to draw an enclosure. Inside the enclosure you will see non-leaf nodes, and outside that enclosure you will see leaf nodes. Now you see a green enclosure. Inside this there are 6 nodes. I am telling the values in the sequence from the top: 5, 6, 7, 3, 4, 9. These 6 nodes are called non-leaf nodes because these nodes have at least one children, at least one node attached with with any of these nodes. So this build max heap function, understanding of this build max heap function starts. I have read the values from the top, but the working for this build max heap happens from the last in the opposite direction. That is, the working will start from 9, 4, 3, 7, 6, 5. I have read the nodal values in the opposite direction, and in that direction we have the node, 6 node, and we have to make make each of these node under the influence of max hippify function. In other words, we have to max hippify these nodes, and I start now. And if you remember the max hippify function, then you should keep in mind that in that not only the node but its children are taken into consideration. So the first node to be max hippified here is 9. So I take 9 with its children. I show that part. Now you take Now you see the node 9 with its children, and this part is to be max heapified. What does this mean? This means that here the node is 9 and its children is 12, and 9, that is the parenthood. Here the parent node is 9, and the parent node must contain the larger value. So here 9 and 12 will be interchanged. So I interchange these two values. Now you see I have interchanged, and this enclosure, that is the node 12 with its children 9, this part has been heapified. Now we go for the next node. If you remember the first enclosure, then the next node to be heapified, to be max heapified, will be 4, and so I have to take the node 4 with its children. Now you can see I have taken the next node, that is 4, with its children 1 and 51. Among these you see 51 is greater. So the nodal value, that is 4 and 51, will be interchanged. So I interchange these two values. You see I have interchanged. Now the next node to be max heapified is 3. So I take that 3 with its children. I have taken. In this you see the nodal value is 3, but the largest value is 13. So 3 and 13 will be interchanged. You see, I have interchanged. The next node is 7. But here there is a point to remember. Below 7, you see the children are 12 and 22. And there is a grandchild also. We have to take all children. So the next node is 7. So I take that 7 with its children as well as grandchild. Now you see the node 7 with its different children, and this part must be heapified. So there are four nodes. So first we make a subset of the node with its child. You see, I have made a subset. First, the work is done inside this subset, that is the pink color enclosure, and inside this you see the node is 7, but the largest value is 22. So 7 and 22 will be interchanged. Okay, now you must notice the interchanging part. If you go along the interchanging part, then there is no node after that. I show you. You see that the interchange has taken place along 22/7, the blue line. If you move down this blue line, then there is no node attached with 7. So there is no more work to be done to this node 22. Now the updated node 22. Earlier this was 7. So the entire work of max heapifying inside the green enclosure is complete. Even if you observe the 12, then 12 is greater than 9. So there is no much work inside this green enclosure. So we move to the next node, that is 6, and for that 6, as usual, we have to take the children of 6 as well as the grandchildren of 6. For that, I take an enclosure. I show you that enclosure. you see, and you see the enclosure in which the next node, that is 6, is lying with its children as well as the grandchildren. And again we make a subset of the node and the children. You see the subset of the node, that is 6, and its children 13 and 51. And inside this we will work first inside this green enclosure. If you see, then the nodal value is 6, which is smaller than 51. So 51 and 6 will be interchanged. So I do the same. Now the working with the 51 and 6 is complete. Now you should notice the direction of interchange. Direction of interchange is in this direction. Notice the direction. This is the direction of interchange. And you must remember that in max heap function, if interchange takes place, then we move down in that direction. So we consider now the node 6 with its children. If you observe 6 with its children, that is 614, 614, then among these three 6 is the largest. So there is no need to do extra work here. Our working with the blue enclosure is complete. So I go for the next node, the last node, that is 5. So see the last node, that is 5. You see, the last node is 5, so I have to take this node 5 with its all children, and accordingly here as well we make a subset of 5, the node with its children, the first children. You see, I have taken the subset of the node 5 with its first children, and among these you observe that 51 is the largest. So 51 and 5, the node 5 will be interchanged. Okay, now you observe that 5 and 51 both have been interchanged, but after that we have to observe the direction of interchange. I show you the direction. You see the direction of interchange, though. So in this direction, if you go below, so you have to move left, and in the left side of 51 you observe 5. So now the next sub step, not the step, the sub step is the node 5 with its children. So I take the enclosure with this node 5 and its children. Now you see the interchanged node, that is 5 with its children, and inside this blue enclosure the nodal value is 5, but it is not the largest value. The largest value is 13, so 13 and 5 will be interchanged. Now you observe that 13 and 5 have been interchanged. Now see the direction of interchange. I show you the direction of interchange. So this time as well the direction of interchange is towards the left. So in the left side you see the node 5. So next time I have to take 5 with its children, that is 3 0. So I enclose 5 3 0. and inside this you notice that there is no need to work because the largest value is the nodal value. The parent value is the largest value inside the blue circle, blue enclosure. So we say after completing this sub step, I say that the first node, that is the node at the top, has been max heapified. So we have done the work for the last node. There is no more nodes. So we say that the heap that obtained here in this picture, in this screen, the heap we say now is called max heap, and the process which we followed to get this heap is called build max heap. And this function is very important because this function will be used in the heap sort. So you must understand each and every step of this video. Okay, thanks.